Calls again?
Belly band.
It's a belly band.
Belly band.
That pipe down there going down is a split pipe. It's cast iron with a divider in the middle. So that one half of that wound up going back, tied into the throttle valve, and allowed gas coming in. And we brought it up there and then took it to each of the inlet valves. Now, the belly band is also water cooled, and the cylinder jackets are water cooled. And this is a relief valve there. Somebody's pulled that one apart over there.
Yeah, some of that's missing. This was the burp valve for the detonation. Yeah.
And this was an indicator cock.
That's where you gauge the,
Well, we actually hooked up an indicator so that we could indicate each cylinder
Fine tune it.
to fine tune it.
you could adjust the cylinder pressure to balance.
We could change the ignition to balance the cylinder.
The cylinder, yeah.
So we had the ignition set up, what's going inside.
So you would balance the cylinder by adjusting the timing?
By adjusting the points for that particular cylinder. I changed the system around and put in 12-volt generator, automotive generator. And changed the system over from a magneto system so that we were running straight through. We had a hydraulic governor, and then in here we had separate points for each cylinder. And by adjusting the points for that particular cylinder, we could adjust the firing, how far ahead of dead center we were firing while it's turning.
So it went to a generator with just plain ignition coil ignition.
Right. And then I found that by putting an ignition coil right there on each, see this particular cylinder has 4 plugs in it. 2 on this side, 2 on the other side. And by putting this coil there, we got better control on the firing than we did when we tried it with just one ignition coil.
Fire 4 plugs. Generating time. How far ahead did you typically fire that? Probably depending on the gas.
Well, normally we were between 5 and 7
Degrees. Okay.
Jim, can you tell me about the lubricating system? Was that automatic, or were you pumping that by hand? Or?
No, that was automatic. See that, we drove that through this gearing set up here,
So
through
roller
there,
chain.
so that once the engine was running, those were taken care of, automatic.
Continuously pumped.
Now, how you started telling me how the inside of the cylinder was lubricated.
Well, it's also, one of these cylinders was oil, one was cylinders.
Okay, so one of these was for lubricating various points, and the other was for doing cylinders.
Right.
Okay, and that would be filled with the special
Yeah.
tallow oil.
Yeah.
Okay. That compressor down here, was that the main compressor used?
We had 2 compressors down here. We had one up at the other end. A portion of the building has been torn down. in the cellar down there, and I don't know whether they're still there or not, there were some 20 or so air tanks.
Okay.
Those air tanks came in and fed to a valve here. And this was a starting valve. You'd open this one, would shut it off, but as long as this handle was down, you still were shut off, just nothing more than a quick opening gate. That you could grab that and swing it up, and that then would throw air into the cylinder that you had.
So that would just put air in one particular cylinder?
One particular cylinder at a time. Now, when you look at the, see this gadget right here?
Yes.
That's an air valve. And that thing would come and catch on this slide here, which is right in the back of there. When the air comes on, it will pop a pin out there.
I'll pop a pin out here.
Yeah.
Okay.
Pin from that will pop in. And out when I've got the air on. To put air into the cylinder, the crankshaft comes, will drive that pin in, open the valve, and as you get rotation, as soon as it's off of that slide, not holding it in any longer,
Shuts the air
out, and I'm moving to another cylinder.
Oh, so this would put air in the cylinders progressively.
Progressive.
Okay.
Now, you'd pick a cylinder, pick a one that was coming under compression, which would be that one right over there,
Yeah.
and you'd catch a spot and we'd put a wooden wedge there so as to hold it in at the point we started.
Catch the one that was just past top dead center to get it
Hopefully
coming.
you were right at top. It wasn't always that way, but hopefully it was. Then somebody mentioned about oil. Off of this, we went down to the cellar, and this drove a main oil pump that shoved oil back into the main bearings.
This is a gear drive then.
I saw where they had alarm whistles that would go off if you had a lack of oil pressure to the connecting rod there. There's only one of those left. The rest of them had all been stolen.
God only knows what they're stealing.
There probably isn't much chance of getting them running or something.
Well, this is the compressor left down here, and that runs off
That-
of unusual voltage.
That was ran off for 25 cycles.
25 cycle.
The initial voltage through the plant was all 25 cycle and DC.
DC originally.
So
And like we said earlier, pressure takes these engines, they use gas for these. The ideal propane is the experimental ideal.
now, the first engine that was built stood right along here.
Right here.
But this compressor shoved air to the tanks in the cellar. And that,
CP. Said there was more, or was this the?
there's more. We had this compressor, we had two other compressors up in what we call the middle section, which has been torn down. We had air tanks down in the cellar here, We had air tanks all the way down at the other end of the AC house. There were 7 engines beyond here that were generating 25 powerhouse.
They were reciprocating engines too.
They're just like these,
Okay.
only
They
were
generate
ju-
electricity.
They generate electricity.
Would this compressor be capable of starting with enough air tank, or is that just not gonna happen?
My guess is, without air tanks, it's not enough.
Enough reserve to make it turn?
If I was going to run by air, as I was telling Steve, I would take the air valves out. So I get rid of that load. I've still got to lubricate,
Yeah, first order.
and I would say, set it up in such, if the tanks were there, that you would run the engine with air for 5 or 10 minutes, turning it over.
Get it moving.
Well, that's as far as I'd go.
Yeah,
And if I run by air, you got to remember that as the air expands, it takes heat. And if I ran continually on it,
you're gonna freeze it.
you're going to freeze it, sure in hell.
Yeah.
So I've got to have lubricant in the cylinders and everything to do it, but I'd only run to say 5 or 10 minutes once a day or whatever.
Yeah,
And then whatever time it would take to pump the air cylinders back up, or air tanks back up, I would have to come later.
later, yeah.
When you went to actually start an engine, did they start relatively easily, or sometime were they a little recalcitrant?
I would say both. A great deal depended on if we had real bad gas. Every now and then we'd get gas that cripes,
No BTUs.
no BTU basically. Cripes would be down to like, say,
Breathable.
50 or 60.
Yeah,
And just wasn't enough to do anything. And even with that, you couldn't put enough coke gas or natural gas in
make it light.
to make it a point. The engines originally were designed to be operated on somewhere around 110 BTU gas. As blast furnace burden improved, we got to the point that normal blast furnace gas would be around 90.
We were getting pretty close.
So, no, we operate fine because I finally found out the secret of assembling the engine to make it run smooth. And that becomes in setting the regulating valve on the inlet pistons. I don't know whether there's an inlet valve sitting up there anywhere, Steve, or
I
not.
don't know.
Yeah, we've kind
Good
of
ticket.
looked for inlet valves, and we couldn't find either inlets or exhausts laying around anywhere.
Well, the inlet valve, underneath the valve, there's a regulating piece that has some angular slots.
Okay, I think over here in these parts, there's,
Let's walk around this.
it's here somewhere.
No, it wouldn't go into one of those bins.
Wouldn't fit on the shelf.
I I saw something here somewhere that had angular slots.
Well, there may be some up between the engines, I don't know.
I thought that's what it might be. Oh, here.
Well, that's part of the scavenge engine pump. Up on the 4 and 5, and the twin engines have a scavenger pump. Scavenger pump was built to go in there that at the point just before the exhaust valve closed off, there was a slug of air shoved through the cylinder to purge it.
Okay.
Now, those engines were built, in the late 20s, early 30s. So that's scavenger.
Okay.
Move the air through to purge the cylinder, get a better charge on the intake.
Yeah. That's exactly what it is. Now, this shanty here was used by the that took care of the lubricators and the air valves. So when we would take the air valves off, they'd be brought down here, they would clean them up, and put them back together ready for next year.
And that was the starting air valves?
No, not starting, compressor, inlet and discharge.
Okay, yeah, okay.
For the air compressors.
For the air compressor,
You're blowing in.
yeah.
Okay.
And they also took care of all of the maintenance of the lubricators. And they required quite a bit.
Those are the valves
The valves I'm talking about.
on the end of the
End of the cylinder, yeah. Somebody has stripped off some of those already.
Do you know anything about the explosion they had here in the early 90s?
Sure.
Okay. What caused that?
Air valves.
Air valves.
Yeah. They called me late in the game and came down and I told them, pointed out to them on number 5 engine, if you take that particular air valve off, you'll see it burn. Somewhere somebody decided to change from Bakelite disc back to steel disc, and you get one leaking, and the compressed air gets damn hot, and then you start ignition.
So, well, what was the source of fuel, though?
What? What do you mean? Where was it? Now, come on, you tell me.
Well, I mean, this is the blowing side, so you're basically just blowing air. I know when you compress air, it gets hot,
Okay,
but,
but what?
Oil in the compressor.
Where's the air?
just residual oil.
You gotta put oil into that cylinder
Yeah.
To lubricate.
to lubricate it, and it goes on through. Periodically, we had to drain oil out of the coal blast mains.
Okay.
So you say, do you have fuel? Hell
Yeah.
yeah, you got fuel, a lot of it.
Yeah.
Got a lot of hot air, that made a hell of a thing.
If I interrupt for a moment. Do we have any dust masks?
And my guess would be that you're going to probably need a horsepower, then would come probably, just as a guess, 2/3 of what it would be
Yeah, because you had a
if
little,
the,
had a little excess on the air. Yeah.
so what would that number
It's
be?
a lot of horsepower.
It's a lot of horsepower, no question. I wouldn't try to give you a number right now.
Well, it can be
Well,
calculated.
yeah.
I'd say it's one of those
if
things
you-
that You gotta run through the number.
You figure out the area of a 47-inch piston
Yeah.
in square inches and then multiply 225 times that.
Convert that back.
That's
That's a big
lot
number.
of pressure.
It's a big number. It's
Big
not gonna
number.
be easy. Now, this is the frame right here for number one engine. Why did they leave it here? I don't know. You know, Steve?
No, I don't. It looks like they were stripping parts at some point.
Well, somebody somewhere, now, this main frame will go down about 6 or 8 feet. The only way they get those things out, they'd have to break them up.
Have to cut them up, yeah.
When we put those in there, we actually took the wall out and rolled them in and slowly lowered them down by taking cribbing out from under the ring.
Wow.
Well, the crane
So
wouldn't-
you probably a couple hundred tons of weight here.
crane wouldn't touch
Couple
it.
of hundred tons, a lot more than a couple hundred tons.
Okay.
So they've taken, the flywheel would have been right along here. So they've taken this up.
Down to what's easily removable, and the rest of it's just iron.
Now, this was another part of the regulation. This is a T-valve in there and set where the inlet valve would come through. So that I've got some degree of regulation here as to the ratio of gas and air in the air.
How did you set the fuel air ratio? Was that?
Right up here. Right.
I-
Probably listen to the machine, right? You know
Well,
if it was running optimal?
no. Basically, when you set the air ratio, you did it by running indicator cards. We would move this one a little bit, but primarily on the inlet valve, we had to set that before the inlet valve was set.
Because I'm sure there'd be minor variations, wouldn't there, in the chemistry of the gas that was coming off?
Right, yeah, he said that.
Oh,
Every
okay.
5 minutes.
Every 5 minutes?
Yeah.
Okay, I was just taking a wild guess. Sir.
Yeah, the gas varied quite a bit in BTU.
Uh-huh.
We took gas samples, I don't know how many thousands we took. And we'd take a sample of gas, and you could check it right now before you could get it to the lab and get the results back. It'd already changed.
Yeah.
So basically, we went by the indicator card and the results that we got on the indicator cards.
Did you have the indicators hooked up all the time or
No.
only when you had problems?
Well, no, not just only when we had problems. I had 2 people that did nothing but indicator work. Their job was to run indicator cards and take care of keeping the spark plugs clean. So if they weren't busy at something else, they were running indicator. If we knew an engine was
Didn't sound right.
pumping, and you could stand on the main bearings, and you could tell whether it was running smooth by just standing there, and you could feel it on your feet as to whether it was going smooth. So if an engine was not running smooth, they would go immediately to that engine and start indicating. Otherwise, if they had nothing else to do, we shot to have every engine in the house indicated at least once a month.
Were these machines made in-house here?
Oh, yeah, they were all built here.
Oh, yeah,
Yeah.
yeah.
Yeah, he said to get the main frames in, they actually tore a section of the wall
We
out.
took the whole section of the wall in and
Roll
the
the
frame
main-
would be jacked in.
frame in, and then they roll it in on cribbing, and then take one layer of cribbing out at a time.
Well, we know how to do that.
Yeah.
It's not easy.
No, we moved machines several tons by ourselves. Are these inlet pipes right here?
When you say inlet pipes,
Yeah, I mean gas.
No, that's not
No,
gas.
no,
That's air.
Oh, it's air.
Cold main.
cold blast main. The gas pipes, you gotta remember the cellar underneath here is actually divided. Along just about here, there's a wall that runs all the way up. The backside here, the gas lines came in through the cellar. The air that we pumped to the furnace was pulled out of that cellar.
Keep it evacuated.
Huh?
To keep it evacuated.
Well, not to keep it evacuated, but at least to keep the gas content from building up back there. Each engine had a tank which was a water seal. So that the gas from the blast furnace, we would drain that water seal, and then we had gas up against the throttle.
Okay.
A gate valve, if you keep using it on a throttle, they never will be gas tight.
Leak a little.
They were
So,
probably brass,
huh?
all brass valves.
Not all brass, they're cast iron. When you get
Oh, they
a
were cast iron.
30-inch valve, you're not really making it out of brass. They're out of cast iron.
Oh, okay.
And they are not gas tight. So we never worked on an engine without that water seal there
To shut
that
it
we
off.
had. And we kept water running in that water seal all the time to make sure that,
Stayed tight. Is the basement, is the starting stuff accessible, or is it?
huh?
Well, there's water in the basement that has to get pumped out.
Okay.
Well,
Well, let's call the fire department, get them down here. The hard section. I mean, are we talking inches or feet?
Probably 18 inches, maybe.
18 inches?
Yeah.
In the whole basement?
Well, we go down one of the steps and measure it.
On the water cooling, you
I
said
will.
the cylinder jackets are water cooled. Is there a chance that any of that stuff froze, or would that have drained?
I don't know how they shut down. The danger becomes one. We can look at it. The cylinder is water cooled. The belly band, which is this piece right here,
Yeah.
is water cooled. The belly band takes gas from one half of that pipe there, which goes down to the gas main. The other half is air going back to there for combustion air.
There.
You've got gas coming up one side of that, air up the other side. Now, the cylinder's water cooled, the piston's water cooled, and then this piece of tubing right here, that right there, that's what we call a shotgun tube, from the piston coming back out. So,
Oh, okay, it works like a trombone slide.
yeah,
Okay,
well, I gotta
yeah.
get it in and out,
Yeah,
that damn
yeah.
thing's moving.
Yeah,
Yeah.
yeah. So that would, you'd have a 5-foot stroke there naturally.
Oh, yeah.
Yeah.
So hopefully when they shut down, they drain.
Well, if we shut down during a strike, we would open up and we would spray the inside of the cylinders with oil.
Oil, sure.
Now, when they shut down, my guess is that they did nothing.
They just walked away.
Walked away.
That would be my first guess.
What shape is the inside of the cylinder? I don't know. What condition are the piston rings in there? I don't know. Can you remove a piston? Because when you pick up a piston, we had a counterweight that would go into the water hole so that when we picked it up with a crane, it
wouldn't
would
bend it.
balance, that we could stick it in. we could come in and get it in there. You don't have any means right now to disconnect the differential nut that connected those pistons to the intermediate crosshead.
And that's amounts to tooling or,
Huh?
yeah, the tooling to do that.
The tooling to do that was all special stuff. And when I first came here to tighten that differential nut, we built a platform up here and we'd put 8 or 10 men on swinging a 5-ton dolly bar to
think
drive
the-
wrench to tighten it.
Yeah, there's a big steel bar over there that the ends are kind of mushroomed a little bit.
Well,
That's about
you
halfway.
mean maybe the dot, but I quit using that and made a special wrench that we could pull with a crane, and I doubt if that's around anymore. Now, an engine like this, where somebody stripped it out, would I keep it? No. If I had my druthers, I'd tear that frame there out, and I'd tear this engine out. I would tear this engine out, somebody stripped off, evidently started to get rid of this one.
That has a broken crosshead in there. See down there? The crosshead's broken.
Well, they may have burned it to get it out because
Okay.
they didn't know what to do.
Yeah.
That's had a differential nut on it. See, there's a nut that held that thing together that had internal threads and external threads that would pull the crosshead and the piston rod together. So my guess is that whoever was working here didn't know any better, so they took a torch and burnt that piece out of there.
They're scrapping it, they don't care.
Don't care. Now, these are the last two engines that were built, this one and this one. These two engines were built somewhere around
1930.
Yeah. Now, you asked about that one valve down there? See that gadget up there?
Yes. Oh, it's inside there.
Yeah.
Okay.
That's the scavenging pump. That damn baby goes up and down and will throw an air, slug of air that will come in. If I look at the band below this inlet valve part, is bigger than the others. It's got 3 sections in it. One section in there is for that scavenged air to come in, to throw the slug through. There's an air and a gas. So if I was going to keep 2 engines, I would say I would keep these 2.
If the cylinders are in shape, these might be the best if you were ever gonna try and run going on the long
I
shot.
can't really say that. Cylinder liners, we made cylinder liners, they're cast iron, and we would make a cylinder liner, we'd rough machine it, and we'd set it out in the weather for 2 or 3 years before it would ever be used as a liner. Cast iron, surprisingly, will change in size and shape
Yeah.
by just setting out in the
Essentially seasoning the cast.
weather. Yeah. So we found out that if you wanted to get if you wanted to get a good cylinder, you had to do that. Otherwise, the liner. We were continually changing cylinders. So I can't tell you when these cylinders were actually changed out.
how new the cylinders, the liners. are.
How much life would you get out of a cylinder liner?
It varied tremendously. If we broke a piston rings,
Sure.
we could score, and perhaps we might get only a few months. If it had no piston ring problem, we might get 8 or 10 years. So, when were they changed last? I have no earthly idea.
Oh, God. Records would probably be hard to find and
I doubt if they exist.
exist. Okay.
I doubt if they exist. Now, if I had a choice, I would keep these two as single engines. I'd keep one of the last 4 up there, which are double engines. And the only difference of this and that is the others up there have a single flywheel.
Single flywheel connection between the two. Yeah.
So,
If the compressing end was unloaded, how critical is cylinder condition just to making the thing turn? If they're gonna generate revenue, you gotta have something.
that's a hard question.
Yeah. If the rings aren't broken and the cylinder liner is
Well,
in passable shape.
I don't know whether the piston rings are rusted and froze up.
Yeah, because we'd have cast on cast. The rings were probably cast iron.
Yeah.
Yeah, cast.
And they're segmented.
Are there inspection ports on the side of the cylinders
For what?
to, I mean,
Any way to look in or check?
any way to look in?
Well, have you got a bore scope?
Probably could borrow one.
Well,
Can be, yeah.
we had a couple of bore scopes, and yeah, you could take off, and we went from time to time. We'd go through a spark plug hole, or we'd take the indicator cock off
Okay.
and go through that. Yeah, if you've got a bore scope, sure, you can look in.
Look at it. Yeah, yeah, bore scope can be done, yes. But that would give us some idea what they did when they shut it down.
Yeah. Well, I don't know whether it would or not.
Okay. Well, if there was an inch of water laying on the bottom of the cylinder.
Oh, God. I don't know what you'll find. My guess is when they shut down, they did not blow the water system out. When we went down on strike, we would blow all the water systems out to get all the water out. And then we would actually go in and throw some antifreeze in there to make doubly sure.
Yeah.
Now, did we have a piston full of water in these things when they, I don't know.
As a compressed air cycle would have cleaned it all out.
Well, I wouldn't say it would clean it all out. You'd probably get 75%.
Yeah. Enough that you wouldn't have to worry about hydraulicing the cylinder on startup. Yeah. If we were going to look for freeze damage, is there any place that it might be most evident or easily?
Well, the thing that it's hard to say right now, if I was going to turn one over, I would unload all the load I could off of the compressor. Taking the air piston out would also help, but is it worth the effort? Probably not. I would also unload the packing from the shotgun tubes or at least to loosen it up to the point that it was not watertight.
But that's a considerable
If you're going to,
drag.
if you're going to think about running them on propane, then you got to figure on, I got to have water.
Well, let's say you were only to run it for 10 or 15 minutes. You think you could run it without a cooling system, just for that
Well,
short
if it's
amount?
only going to run 10 or 15
Yeah, it would
minutes,
only run
sure.
for 10 or 15
If you're
minutes.
only going to run 10 or 15 minutes, yeah, you could.
Because there's a hell of a lot of mass there that needs to get heated up.
Oh, yeah.
Because, I mean,
No, 10
these
or
things ran
15 minutes, I
24/7.
wouldn't worry about that.
Yeah, so essentially you wouldn't need the cooling system then.
The biggest thing that I've got against propane, one of the bigger problems is, are you going to take that propane and mix it with nitrogen to get it down to a reasonable BTU level? And then where am I going to do that? Where am I going to get a tank of that thing,
Well,
of that mixture?
you know, just thinking out loud, we were speculating as to whether you might be able to do a direct injection of propane into the cylinder using solenoid valves and micro switches so that to time it at the right point. Now, granted, we're not going to run this thing at full power. It's only
Well,
enough
I'm not
power,
in- I'm just-
just
I-
enough
I-
power to make that flywheel go around a
Well,
little bit.
I don't say it couldn't be done, but it's going to take a hell of a lot of
Technical work.
technical work by somebody to get it to that point.
Yeah.
I think if it were me, I would be more inclined to put my effort on turning it over with air for a little bit
Yeah.
than the other.
As a long-term thing, though, if we can get it.
I've got to,
yeah.
even if I do the propane bit, I've still got to get enough air to turn it over to get it started.
Right, yes, yeah. So that's a given.
That's a given. I got to have air to get it started. You're not going to start it with propane
Oh, yeah, I
without
realize
the
that,
air.
yeah.
So I've got to go that far.
Well, do you know what the compression ratio was approximately?
You said about 10, 12.
High.
High.
We were running 12 to 13
To 1?
ratio. Yes.
Whoa, that's
Yes.
high.
Yes.
I mean, that's as
Yes.
high as a high-performance
Yes.
automobile. And that's
Yes.
because of the low,
Not anymore, but
the
Well, all
low,
right, but I'm just saying. These were very efficient engines.
yeah.
yes, they were.
They were well engineered.
For an era when gasoline engines were in the
Right.
10% range,
Right.
these were
So
incredible.
don't think about this thing as something that's got a low compression.
Yeah,
engine.
I thought the compression ratio might have been
Oh, hell
5 or
no.
6 to 1.
Oh, no, 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 no.
Whoa,
That throws a different light on things.
yes,
doesn't
it does, yeah.
So, no,
As you can calculate that back from, you said 185 pounds running, roughly.
well, topic pressure on indicator cards, I like to have between 180 and 190.
Yeah, as you can calculate that back with the swept volume of the cylinder and the engine RPM and come up with
So,
static
yeah,
compression. But
yeah.
what was the governed, what RPM did you like,
60, I think it was.
60?
On these engines, no, that was not the case at all.
Okay,
On just the,
On these engines, the blast furnace, say, would ask for, just taking a number, 50,000 cubic feet. We made a correction for barometric pressure, temperature,
air density.
moisture, and the whole works. And then we set the speed of the engine to give us that amount. So each engine was regulated, and I was actually holding the guys to a half an RPM. What?
that's pretty good,
Well, look,
yeah.
even that still becomes a big number.
Okay. Yeah, I guess when you yeah.
The percentage number.
You
That's
take,
yeah.
you take an engine like this, that single engine, I figured that engine there was good for 20,000 CFM. So when I'm running, say, 60 RPM, 1 RPM makes a hell of a big difference.
Difference in
Yeah.
output, yeah. Yeah. What kind of head pressure did they shoot for?
You didn't.
You didn't.
You took whatever the furnace gave you.
There you go, okay. They limited,
It ran, huh?
they limited the flow.
They didn't limit it either.
They didn't,
The burden of iron ore, coke, and stone in the furnace determined what pressure
was gonna be, that was
you
the,
needed to get it through it.
okay,
So it might be 15 pounds, it might be 35 pounds.
yeah, with low pressure air in any event, yeah.
Huh?
Pretty low pressure.
Well,
yeah. That's an
high
awful lot-
volume.
Awful lot of air.
it's a lot of volume, but it's not what you would, I wouldn't call 30 pounds particularly high pressure.
Yeah, no. But back to the water damage thing, was there any particular place where you might see the jacket crack or something that might? If they shut off the water supply to the engines, the cooling supply, did the cooling water, there was some means of radiator here on the works, or did they just run a city water supply, or how did they cool or
Probably
chill the water?
The water from
Pulled out of the river maybe.
the water came out of the river.
Okay,
It was dirty. It went through a screen of about a ½ inch mesh screen.
should keep the fish out.
Fish, minnows, frogs.
At the time, back in the 50s, early 50s, the Lehigh River was an open sewer.
Sewer, there wasn't any fish, you're right.
Yeah.
Yeah. You had to float other things out.
Yeah.
I've seen a time when we took dead dogs out and then cats out of the
Sure,
pumps.
yeah,
They'd get into the impeller of a pump.
yeah.
So it was dirty. I wouldn't get too alarmed about the water.
If they shut the
If
pumps
you're
down,
gonna,
it might
if you're
very well-
going to just turn it over with air, I would hope by putting some lubricant in the cylinders that you'll probably find the cylinders rusty inside. Hopefully there was enough lubricant at the time they shut down that the rings did not lock up.
Seized to the
from rust.
walls, yeah.
Under any condition before starting up, I would want to say take a crane and turn the engine over with
Manually pull the
pulling
wheel
the
over.
flywheel over to turn it through. Under any case,
Sure,
I wouldn't say clean an engine up and then say, okay, I'm gonna hit it with air and see what will happen.
manually turning the engine over is the first.
Manually pull it over through a couple of revolutions with a crane.
Okay. And maybe a silly question, they just hooked a spoke with a crane, and
Huh?
how did they,
Well, we had a special, what we call a crane hook.
crane hook, okay.
And it happened more than I would like to admit, but there were quite a number of times that they would yell over a loudspeaker system, crane hook. And you knew as soon as it was engine, for one reason or another, either they were just putting it on a furnace or there'd been something happen at the furnace that caused the engine to overload and lay down, that you needed to get it off a dead center. So, but we had a special hook that the guy could hang on the crane. He could drop down there and get on at the spoke and turn it over.
Okay. Actually hook the spoke, or is that something you could make us a picture of? They were fairly
Well,
optimistic about getting the crane going, I think, weren't they? Did that?
Well,
Yeah,
right now, rather than try to say, go make a crane hook, I would say I'd get a sling. I would throw the sling around there to the crane hook and pull it over with that rather than, when you start making a crane hook, that's going to be a fairly expensive item. Even if I burn it out of a chunk of plate, I'm going to have to burn it out of probably 2.5 or 3 inch plate.
Okay, well, yeah, as long as there's some reasonable way, otherwise,
Well,
that's what we need your
you can get a
expertise.
sling, it's
Yeah,
no
nylon
great sweat.
sling.
Yeah.
I wouldn't say nylon, use steel.
oh, okay,
Use
steel
a wire
sling.
steel sling.
Wire rope sling.
Steel. I don't have to go get a nylon sling.
We don't want to scar the spoke. You just hook it right around the...
Huh? Oh, that's easy. That would be the easiest thing in the world to throw.
Yeah.
Huh?
You get a quarter turn out of it.
Oh, you can get about a quarter of a turn. In other words, I could get on the scoop down here and pull the damn thing up there. That's no sweat.
And they rotated counterclockwise as we're looking at it, or clockwise as we're looking at that.
Towards the back wall, towards the north.
And you said, how much did each of these flywheels weigh?
They vary. It depended on the engine and the size of the air tub. See, the air tubs are not all the same diameter. They run from 62 inches in diameter to 84.
Okay.
So they vary. So the flywheels vary also.
Designed to fit the compressor.
Particular one.
Tachometer.
Well, that was one of those gadgets somebody decided to try and
Didn't work so well.
didn't work. So
Peeking down the stairway, it looked dry down there. Has that water level been recently, or?
I think it depends on weather,
Oh, okay.
because we sealed the sumps in the basement, because we didn't want anything else after we shut down going out to the river. So I checked with Joe Cuck, who knew this place, and it's sealed, so depending on how much rain you have, you get accumulation, and then some of it,
Drains a little bit,
Drains.
yeah.
But our concern was, you had to ask the question before we start power washing around here, and things go into the basement, are we going to see it in the river?
I was, yeah.
The answer is no. Yeah.
We'll see it accumulate in the basement to go somewhere.
It'll just, it'll be in the basement. Maybe we'll pump it out if it gets too
that
deep.
point.
okay, what other question you got?
Well, that
I
was,
think they took off, I think Joe said they took all the oil filters off, which were in the basement.
Well,
So he said, before you start messing around with oil, you better check.
there was a double system, really. Coming off of the end of the crank shaft, went down to an oil pump with the main pump. Off of the tank down there in the bottom, we had against the wall, and probably what you're thinking about, we had a filtration system that we took the oil from that tank through a filter and then back into the tank. I would hope that tank, the main oil tank and pump is still there. I don't know that, but
Yeah, I don't know, we'll have to take,
Huh?
I don't know,
I don't know either.
yeah.
The oil pump that pressure lubricated the bearings, that was electrically driven, wasn't it?
No.
It was mechanically.
Oh, hell yes.
Okay.
We didn't depend on any electricity.
well, you had an engine running. You had
Everything was strictly independent.
Well, didn't you want to pre-pressurize the bearings before you started an engine up?
We
or-
couldn't.
Well, so,
We came right here from here down to the main oil tank. And all the main frame and all, the oil drained into here.
There wasn't any way to pre-lube the
No,
bearing system.
no. Now, what I would like to see in the course of somebody reconditioning an engine, in the early stages, all of these were lubricated by a grease cup.
Grease cup.
And a guy would come here and every hour, he was supposed to turn that grease cup a quarter of a turn. Here, up on the top on the inlet valve. With OSHA coming in the picture, they started screaming bloody murder.
Oh, because it's moving.
So then they started putting a system in, and
Okay, so that you didn't have to physically reach in there and grab it that way.
Do you know what the firing order was? The firing order of the cylinders?
you mean which one fired first?
Right. I mean, was it this one and then, you know, the,
Whichever one passed top dead center.
I don't remember the exact, it was this one, then the far one.
you would get 2 power strokes per revolution?
It's a 4-cycle engine,
Right.
just like.
I made a little
four-cycle.
sketch over here. We can, I'll show it to you. Maybe you can critique it. I'll bring it over.
Okay.
How high are those ground bases?
They're not high, tall, they're not high. All right, sure. There's water there,
A couple inches of water
a couple
right now.
of inches.
So what kind of equipment was down there, like pump-wise?
Mostly lubrication stuff, it sounds like.
The whole exhaust system was underneath.
Huh?
The whole exhaust system?
The exhaust system came down and outside and up a stack on the single engine.
And
Now,
all-
did the stacks also muffle the sound, or is it just to get it out of there?
We tried a lot of things to muffle sound. It didn't work.
Now, at the far end on the outside,
The far end on
at the
outs-
exhaust system, there were boilers?
On the twin engines, all had boilers.
Okay, these black lines would represent cylinder heads,
Yeah.
and that's pistons. So,
Well, now wait, you don't have enough cylinder heads.
don't have enough cylinder heads.
I gotta have a cylinder head here. I gotta have a. Is that cylinder, this end and this edge for this one?
Yeah, right.
But I
I
got.
don't have the gaps in between where
Oh,
the
okay,
intakes
all
would
right, just so I understand
Yeah.
what you're putting down.
be. Yeah.
Okay.
So if you go down the line here, that's under compression, that's firing, and then we'd have exhaust with moving this way, and then intake again that way. And then if this one's on intake, it's on compressing,
Shouldn't-
and then firing,
Yep,
and then exhausting.
Right. yep. That's okay.
All right.
The firing order is a 2-cylinder, it wouldn't matter which end you fired first. It's gonna-
Well,
As long as the cylinder's up on compression,
you gotta remember the rotation.
rotation.
The flywheel
Rotates
was running
towards
towards
the
the wall.
Okay.
So I've got to do that because of the timing of the crankshaft.
The crankshaft. Okay.
Did you ever have an engine backfire?
Oh, hell yes.
That's out the burp valve.
To the point that with nitrogen, or with hydrogen once, we had pre-ignition to the point that we actually blew the cylinder head off, and some of those nuts went right through the wall.
Whoa.
The pre-ignition was just unbelievable. And when the cylinder
And I
outside-
mean, well, see, the engines that don't have a complete cover on the tailpiece, and really, That was a good deal because it made it easy for a man to see and count the revolutions of the engine. But if you were standing in back of that damn thing and that thing lets go,
Detonated.
forget it.
Yeah. Stand real close.
So it was a no-no to stand in back of tailpiece
Tailpieces, yeah.
when the engine was running.
Now, is there a reason for the different cover styles on these?
Just over time, didn't mean anything.
Whichever engineer
This,
was.
these two engines here were the last two to get fixed. That cover up there, all it was to keep oil from splashing all
all
over.
over.
It worked just as well as this one.
Same,
Thing.
Now, I noticed on some engines, they'll have rounded holes, I guess in the middle section of the cylinders where the gas would come through. I guess like from an old ignition system. Not on the, you can't see it on this engine, but on the next one over, you can see it.
What?
Oh, these holes right here and here.
What is that hole? At one point, that wound up as water getting into the piece.
in the
So,
belly band.
that didn't mean anything. That was where I had water into that cooling for the belly band.
And how does this big stack outside work, the one that has the cover over it at the far corner of the building? I guess the northeast corner. It's just outside the building actually, but it goes down to the basement.
Show me. I'm not sure what.
Yeah,
And it was a central exhaust for the 5 inches that was here.
No.
Because that
No.
didn't have these exhaust stacks at that time.
No. That stack was an intake for air to get into the north cellar along there, for intake air to the compressors.
Okay.
And the size of the stack, that's a great big round stack.
Yeah.
Oh, I don't know, 10 or 12 feet in diameter. And that was put up high so as to get up, hopefully, that we didn't get all the dirt coming in with the air.
Okay, so that's your air intake.
That was an air intake to that cellar.
Okay.
And is there any connection between the two cellars? Between this side and that?
No, they were separate. That cellar over there had the gas lines coming in to feed fuel to the engines. And we also pulled air that we were compressing out of there.
Yeah, we talked about that.
Yeah.
And you would leave that cellar separate from this one here to keep in case of gas leaks.
That was part of it, yes.
Do they have a means of venting the cellar then to get the gas out if it accumulated?
If you got gas accumulated in the cellar over here, you were in trouble. You stayed out of it. You didn't go down.
Did that happen?
Sure.
were there sirens or something to indicate the
No.
gas accumulation?
No.
Canaries?
Huh?
Canaries?
Somebody made this guy down, he didn't come back. Yeah,
No.
Coke gas heavier than air?
Huh?
Coke gas or
Blast
is heavier than air or lighter?
It's heavier.
It's heavier, so it would settle.
I was standing one day, as close as I'm standing to you, and I had some riggers up in the air putting a blank in a blast furnace gas line. All of a sudden he started running. And I said, gee, he's got gas. I caught him about 100 yards. We got him to the dispensary. He had enough gas to kill him. We They ran blood tests on him, ran blood tests on me. He was way up on gas. I didn't have a damn thing, yet we're standing.
Well, you were immune by that time.
Not immune like hell. Nobody got immune to it. But there was a standard rule that nobody went to the cellar alone.
Without a safety guy, sure.
Huh?
Yeah, without a safety guy along, somebody,
Well, we had always somebody else, and they weren't to be walking together.
yeah.
They were to stay within sight of each other, but no closer.
Yeah. We can take a peek at that basement, that compressed thing is still, there
I'm
isn't.
not sure what the light is like down there.
There ain't no light
Yeah,
down
no,
there.
that's, and we don't have any lights with us, but I think that's for someday we have to do that. How many engines were running on a normal day? Were they all running, or you ran them according to the demand of the furnace?
It all depended on how many furnaces were running and how much there were. We never ran them all together. We always had several engines down. So if we had trouble, ignition problems or whatever with one engine, we could switch to another and replace it.
Do you know when and why some of the engines were taken out, like numbers 12 and 13?
Oh, somebody got tired of looking at them, decided didn't want them anymore, and took them out.
The turbo blowers, did they run on steam?
They ran on steam.
Okay.
Did you ever talk to other plants that operated these engines, like Lackawanna or Steelton, or?
They had engines like this at Lackawanna. They had them at Sparrows Point. There were a number of these engines sold to other companies.
We think these are the last existing.
I would think
Engine.
so. I don't know. I know the ones in Lackawanna got torn out back in the 70s. I was up there in the 70s, and I know that. I'm not sure exactly when the Sparrows Point engines went out. The ones at Steelton went out somewhere back in the 30s or 40s, early 40s. There were a few engines over in Coatesville, and when McClank Marshall got shut down, they moved a couple of those engines to here.
Mm-hmm.
That was in the 30s. So
Were those blowing engines or some other type?
they were blowing engines.
Do you remember anything about the Southwark steam engines they used to have here?
Yep. Around.
Wow.
There were 3 of those engines. They stood in what we call the middle section.
What did you call this section?
This was the blowing engine. We had the blowing engine house, the middle section, and then the AC house was on the far end. There were 7 twin engines up in the AC house generating electric power.
Do you know where the steam from the boilers out here went to? Did it just go into the general plant, or did it go somewhere
They
specific?
went to the general plant system.
Okay.
Did you know Tom Law?
Oh, yeah,
Okay, that's a friend of mine's dad.
yeah. I knew Tom well. Played golf with him many a time.
Okay. I'll have to tell Doug.
Somebody who used to visit this place said they used to have steam injectors on the wall, I think by the twin engines. Do you remember those?
Steam injectors?
Yeah, steam, I guess for moving water, or I'm not sure exactly what the purpose was. But I know they were made, foreign made. Kind of like the same injector on a locomotive, do you let you put water in the boiler with that kind of injector?
At one point, we had a steam injector on each one of the boilers to inject water into the boiler.
Okay. So it didn't have anything to do with the engines then?
Didn't have anything to do with the engine at all.
Let's take a walk over to the center section.
Changed a big piston like that for the air cylinders.
How did you change it? You picked it up with a crane with a counterbalance and you put it in.
Okay.
You didn't do it in 5 minutes.
And how about for the power cylinders, the same thing, or is there any special techniques you have to do to get them to fit
We
in?
had special equipment to take and install.
Looks like the basement's fairly dry now. I mean,
I
it's
can
still
see
wet,
it.
yeah, there's, but it's,
water. I don't-
yeah, there's,
I don't know how to,
yeah.
but I'm afraid from what I can see through there, that they've torn out the main oil pump and probably the oil tank.
Was that like a reciprocating pump or?
It was more or less a gear pump. You know what a gear pump is? Are you familiar with gear pumps? It was a gear type pump. But
That, what's that device up there with the gears on it? Is that something used in maintenance? Some kind of a resurfacer?
it was
Resurface the valve seat?
normally we would take the whole cylinder out and get
Take
the
it to the
cylinder.
shop.
Take it to the shop. It was a hell of a lot easier to do that than it was to mess with it. But here again, something like this, I
And
don't see adding to the,
Do you have any idea how the casting got cracked down there?
Where's the crack?
which one, where are you talking?
Right on the bed plate there. I guess the big hole in it is, how did that get there?
I don't see anything unusual. That's just the way it was cast.
You're talking about this?
Yeah, I say that's just, that was in the casting, that was.
Yeah,
part of the
it could have
way-
been part of the runner system or something
Yeah.
to pour the metal in.
Yeah, it's not, nothing.
Okay.
But here you can see where I was talking about the split pipe,
Right.
Okay,
so that half of that, one side of that would be air, the other half would be gas.
okay. So that whole pipe was made that way?
Oh, yeah,
Okay.
all the way back to the gas main. Mm-hmm. And the pipe, the piece from there up here was the same way. So half of that came up one side of the belly band here and the other half up the other.
Well, somebody told me a while back there was an accident where a crosshead got loose or something and went flying through the wall. Does that ring a bell?
Where the, where the head came off and we hit and drove stuff through the wall? Or are you thinking about one?
Well, a person told me it was actually the crosshead, one of the larger.
Well, that was
pieces.
up in the AC house,
Oh, it was.
where the crosshead cracked and the connecting rod then flipped over towards the back. It didn't go beyond. Nobody hurt, no particular damage.
Were they able to reconnect it? Did they fix it?
Sure, we had the engine running in a couple of days.
Did you guys ever have any roof problems when you worked here, or was it kept in good shape?
Well, it wasn't in the shape it is you see today.
Yeah.
Well, one of the biggest things I'm seeing right off is it looks very much as though you're going to have to get a main oil pump. I'm fearful of what I can see without going downstairs that they've ripped that stuff out to keep oil from getting to the oil.
So to run one engine, what kind of capacity tank are we talking about, like gallon-wise?
Oh,
And is it a pressurized tank, or just open to the air?
Well, it's not a pressurized tank, it's a reservoir and a pump.
yeah. There was probably, maybe 300 gallons of oil in that tank, and the pump was down in the tank.
And that tank serviced several engines or just
No,
one?
each engine had its own system.
Okay.
Each engine coming off of the crankshaft, that shaft went down and drove the pump. So all of the oil that went into the crosshead, the main burns and all, drained back to that high gravity, and then got pumped out. And then separately from that tank, along the wall here, there was some Can you see it straight across? Not down the steps, straight across. Is there anything there?
Well, I can't see straight across because there's concrete, it's all like bolted concrete.
Well, if you can't see across, then it's gone.
Got a flashlight down in the car.
I don't want to encourage.
If we got some 50-ton jacks and railroad ties as cribbing.
Jim suggested that it be, turn them over, a few
Over
RP.
the crane.
A few RP, rotate them a few times, because even with the crane, you basically can only rotate it about a quarter of a turn at
Right.
a time.
Is there a special way to hook onto the flywheels?
Well,
Like
they had a special hook, and he said you could use a steel sling.
Steel sling.
Yeah.
There's one.
Is there electricity?
Huh? What's that?
There's no
electricity.
There's no electricity in the shop at all. The cranes run on DC.
I know how you guys can fix, they have the equipment to adjust that.
Well, there were DC lines running through the whole plant.
Right.
Oh, yeah.
Since it's all local, might as well go DC. I don't know at what distance AC becomes more practical than DC.
Well, we had throughout the plant, probably 500 or 600 MG6. So when you start transmitting DC, we were using million ohm cable. They were copper like that.
Uh-huh.
So,
I think part of the problem, they started out on AC. And
Like I said, it's practical.
Well,
I mean, once you start getting into
and
distances of maybe 10
when something
miles
better
and-
comes along, they didn't necessarily want to get rid of everything they already had.
well, it wasn't economical to do it. There were any number of studies made. See, with DC, you got basically finite control.
Right.
When you go to AC, until just recent years, you had no control.
Right.
So, and they started out originally with 25 cycle. All of the AC engines up in the other house were 25 cycle.
Yeah, someone explained to me why the 25 cycle on it basically had to do with the limitations back when it was put in around 1910 or whatever. That when they did the first AC power generation at Niagara Falls, that was all 25 cycle.
I've heard any number of different stories. None of them. If somebody decided, well, 25 is an easy number to divide, they kept going. And then when they got into incandescent light bulbs, they found 25 cycle would flicker. You can actually see it. So then somebody decided, well, we'll go to 60 cycle and get rid of the flicker. So it made sense to do it. While we had 25 cycle generation in the plant, the coal regions up, they were running on 25 cycle. And when PP&L took over up at Hotto, there was a 25 cycle generating plant for the coal. And we bought all that power when the coal mine went down. And then they also had a freight changer down in Freemansburg, down in the plant. There was a 60 cycle driving 25 cycle generator. We had a freight changer down in the #1 Powerhouse area where we had a 25 cycle steam generator, turbine generator. So, and then throughout the whole plant, as I say, there were some 500 or 600 MG sets to get DC power.
So you started here in what year?
42, just before the war.
Lehigh graduate?
No,
Texas A&M?
no.
That's my second choice.
Georgia Tech.
Georgia Tech.
Were you a local boy or were you from?
No,
Where were
I
you?
was from the South. I'd been working for Tennessee Coal and Iron, and I didn't like the politics I was seeing there and decided to come here, where I'd heard it was better. Actually, politics here were no goddamn different from any other big company, to be perfectly honest about it. I was very fortunate. I saw all phases of the operation. I had both operation and maintenance in here. So,
How many years did you complete with Bethlehem?
huh?
How many?
41.
41 at Bethlehem. Well, Jim, I want to thank you very much
Oh, no
for the
problem.
effort today, and hope we can call on you again
Oh, anytime.
when you get down to some
As long
specifics.
as
that we
I'm still
start.
alive.
Looks like you're doing just fine.